On December 15, 2020, an otherwise ordinary day at the Irkutsk Aircraft Plant, the MC-21-310 Airliner completed its maiden flight, marking a transformative step for Russian aviation. This flight wasn't just a milestone for the MC-21-310, it highlighted the success of the PD-14 engine, Russia's first domestically developed civil aircraft engine in decades. Fast forward to 2024, and the MC-21-310, powered by the PD-14, is now poised to enter commercial service. This engine, symbolizing years of engineering, national ambition, and a commitment to technological independence, now stands ready to redefine Russian aviation in the global market. The late 2000s were a transformative time for Russian civil aviation, with the launch of the SSJ-100 signaling a revival. Yet, this wasn't enough. The ultimate goal was the MC-21, a modern, medium-haul jet designed to break into the market dominated by Western giants like the Boeing 737 and Airbus A320. This would require more than just innovative design and passenger comfort. The MC-21 needed a competitive engine to be viable globally. While initially, it seemed more straightforward to rely on foreign engines, geopolitical realities, and a push for autonomy led to the decision to develop a domestic option. The United Engine Corporation took on this challenge, setting a goal to build an engine that wasn't merely functional, but competitive, efficient, and symbolic of Russia's engineering capabilities. The result would be the PD-14, an engine not only tailored to the MC-21, but one that could lead to a new family of engines, signaling Russia's commitment to self-reliance and technological prowess. Creating the PD-14 meant standing up against engines honed over decades by global leaders. Companies like Rolls-Royce, Pratt & Whitney, and General Electric had spent decades fine-tuning technologies and advancing materials science, resulting in some of the most sophisticated engines in history. Russian engineers viewed this challenge as an opportunity to leapfrog with a fresh perspective. Their goal was to build something dependable, innovative, and robust, without risking untested technologies. They decided to draw on a mix of established methods and cutting-edge solutions in areas such as materials and aerodynamics. Through strategic decisions, the engineers balanced the PD-14's complexity with reliability, opting for materials that would ensure durability even as the engine reached high-performance metrics. Russia's aviation engineers were acutely aware that this wasn't just about producing an engine. It was about staking their claim in a market long dominated by a few key players. Building the PD-14 required more than technical know-how. It demanded a sweeping modernization of Russia's aviation industry. Facilities that had long relied on older, less efficient methods were suddenly tasked with producing advanced components. To meet the demands, an overhaul began across multiple sectors, not only in terms of machinery, but also workforce. Skilled workers underwent extensive training, learning to handle the complexities of producing high-tech engine parts. The UAC Aviadvigatel, the hub of this initiative, collaborated with Russian universities, aerospace research centers, and large-scale manufacturing facilities to ensure that every aspect of production met international standards. This collaboration created a feedback loop where innovation at one site supported advancements elsewhere, forging an interconnected, efficient ecosystem. By the end of this transformation, Russia's aviation manufacturing had not only caught up, but was now prepared to lead, with facilities capable of supporting current and future generations of engines. With the prototypes ready, the PD-14 embarked on a series of rigorous tests to prove its capabilities. This wasn't a simple process. Ground tests began in 2012, examining every aspect of the engine's structure and resilience. Over time, additional prototypes were constructed, each representing an iteration of improvements based on prior tests. In 2015, the PD-14 made its first test flight under the wing of an IL-76 aircraft, a significant milestone in its journey. This stage involved subjecting the engine to varied flight conditions, ensuring it could handle everything from cold temperatures to high altitudes and rapid power shifts. Over 3 years of testing, adjustments were made to refine the engine's performance, ultimately culminating in its certification by Russian authorities in 2018. Yet, this certification marked the beginning, not the end. The engine continued to undergo further validation to meet international standards. By 2021, the PD-14 was ready for its public debut at the Dubai Air Show, symbolizing a new era of competitive Russian engineering on the world stage. One of the most grueling tests for the PD-14 was exposure to volcanic ash, a simulation meant to protect engines from events like the 2010 Icelandic eruption that grounded flights across Europe. While volcanic eruptions are rare, the ash particles are hazardous to jet engines, leading to significant wear and potential failure if inhaled during flight. Russian engineers recognized this risk and decided to put the PD-14 through an ash endurance test, using real volcanic ash sourced from the Kamchatka region. This wasn't merely about surviving the ash clouds, but ensuring continued performance and reliability in such conditions. The tests exposed the engine to dense ash at high speeds, simulating conditions an aircraft might encounter. By enduring this trial, the PD-14 demonstrated its resilience and durability, standing out among engines that rarely face such harsh testing. These preparations place the PD-14 ahead of its class in durability, making it one of the most resilient engines ready for both everyday and extreme conditions. The PD-14's core design embodies a balance of efficiency, power, and durability. This fifth-generation dual-bypass turbojet engine uses two distinct air circuits to generate thrust: the core circuit, where air is compressed, ignited, and expelled, and the bypass, which sends air through a large fan to maximize thrust. Within the core, 11 compression stages raise the air pressure nearly 40 times, transforming a steady airflow into a powerful stream. This compressed air, now heated by the combustion process, reaches temperatures nearing 2,000 degrees Celsius, requiring advanced engineering to avoid overheating. Special ceramic coatings and meticulously designed cooling channels protect internal components, ensuring durability under high-stress, high-heat conditions. The PD-14's robust design allows it to maintain a steady balance between power output and energy consumption, delivering reliable performance without sacrificing longevity. Each component, from the compressor to the turbine, is carefully crafted to withstand the rigorous demands of modern flight, underscoring the PD-14's role as a high-performance yet sustainable engine. The fan, a signature feature of the PD-14, is crafted from hollow titanium blades, a choice that combines strength with weight reduction, making the engine more efficient without sacrificing durability. Competing engines often utilize composite materials, but Russia's titanium blades offer a cost-effective, reliable alternative. These hollow titanium blades create a unique balance, adding enough thrust through the bypass to make the engine competitive in fuel efficiency without the high production costs associated with composites. The fan's design, paired with the PD-14's bypass ratio of 8.5:1, optimizes airflow, enhancing both thrust and fuel economy. This bypass ratio means that more air flows around the engine core than through it, creating a quieter, more fuel-efficient flight. Russian engineers saw this as an optimal compromise, allowing the PD-14 to deliver consistent performance while keeping costs manageable. This approach showcases a commitment to not just performance, but also operational economy, ensuring that the PD-14 is both a powerful and financially viable choice. Environmental responsibility was a driving factor in the PD-14's development. Traditional Russian engines were powerful but fuel-intensive, yet the PD-14 manages to improve on these foundations. It offers a 12 to 16% boost in fuel efficiency compared to its predecessors, translating to fewer emissions and cost savings for operators. With emissions reduced by approximately 30%, the PD-14 supports global aviation's push towards sustainability, meeting or exceeding modern regulatory standards. This efficiency is partially due to its bypass design, which ensures consistent performance across various flight speeds. While environmental factors played a critical role, the PD-14 also excels in traditional performance metrics, balancing fuel economy with power output. This environmentally friendly design makes it a forward-thinking engine, well-suited to meet the aviation industry's shifting standards. As airlines face increased pressure to reduce carbon footprints, the PD-14 offers a valuable solution that combines environmental responsibility with operational effectiveness. The PD-14 incorporates a sophisticated web of electronics, handling fuel regulation, temperature management, and airflow adjustment in real time. Unlike older engines that depended on hydraulics, the PD-14's operations are largely automated, overseen by electronic systems designed by UEC Star. This evolution significantly reduces mechanical wear, improving reliability while decreasing maintenance needs. By centralizing control into an advanced electronic brain, the PD-14 adapts quickly to shifts in flight conditions, automatically fine-tuning performance to match the demands of each phase of flight. Additionally, these electronics monitor engine health, alerting maintenance crews of any issues before they escalate. This integration of smart controls makes the PD-14 a highly responsive engine, capable of managing various parameters with precision. The streamlined automation not only boosts efficiency, but provides peace of mind for operators who benefit from increased reliability and fewer unexpected repairs, ensuring smooth, cost-effective, and reliable service. Understanding that engine support is just as crucial as design, United Engine Corporation began creating a comprehensive maintenance network well before the PD-14 was widely deployed. From repair facilities and spare part logistics to dedicated training centers, UEC ensured a robust support system to keep the PD-14 in peak condition throughout its service life. Strategic centers were established across Russia and in international markets, making it easy to access parts and technical expertise wherever the engine is in use. This infrastructure means that operators can rely on rapid turnaround for repairs, minimal downtime, and consistent maintenance quality. UEC's commitment to post-sales support ensures that the PD-14 is not only well-built but well-maintained, securing its long-term reliability and appeal. This extensive network allows Russian aviation to step confidently onto the world stage, promising both high-quality performance and unmatched support, ensuring the PD-14's success as a reliable option for airlines around the globe. The PD-14 is more than a standalone engine. It's the first in a family of engines designed to support a range of aircraft. Based on the PD-14's technology, Russian engineers are developing the PD-8 for regional jets and the powerful PD-35 for wide-body airliners, expanding Russia's capacity to produce engines across different aircraft classes. Each engine within the PD family leverages lessons learned from the PD-14, creating a cohesive lineup that combines performance with efficiency. The PD-8, for example, will power the SSJ-100, a regional jet vital for Russia's domestic air network, while the PD-35, a larger high-thrust engine, is aimed at long-haul international flights. These engines symbolize Russia's commitment to reduce dependency on foreign technology, fostering an aviation ecosystem that can serve both the local market and international carriers. The PD family is expected to be a major component of Russian aviation's future, providing engines tailored for all types of aircraft needs. Long-term reliability is essential for any engine, and the PD-14's design emphasizes both durability and operational cost efficiency. By using domestically sourced materials and well-tested components, Russia ensures that the PD-14 remains unaffected by external market fluctuations, keeping production costs stable and predictable. Airlines benefit from lower costs over the engine's life cycle, as the PD-14 requires less frequent maintenance than comparable engines, and has fewer points of failure due to its streamlined design. This results in reduced downtime and lower replacement part needs, making it a cost-effective solution for airlines. The PD-14's self-sufficiency in terms of parts and production not only cuts costs, but enhances fleet resilience, ensuring consistent operations even in a fluctuating global market. Operators who invest in the PD-14 gain a reliable and financially practical choice, a critical advantage in an industry where maintenance costs and fuel efficiency determine profitability. Since its launch, the PD-14 has shown strong demand, prompting Russia to ramp up production significantly. Assembly lines and manufacturing plants across Russia were modernized to handle increased output, with the MC-21 airliner production also scaling up. This alignment in production capacities ensures a steady supply for both engines and aircraft, supporting Russia's aim to become a formidable competitor in the global aviation industry. With the PD-14's success, the focus is shifting toward increasing production of upcoming engines like the PD-8 and PD-35, broadening the scope of Russian-made aviation solutions. Russia's commitment to scaling production reflects a long-term strategy to fulfill domestic and international demands while solidifying its footprint in the aviation market. Each new engine strengthens Russia's position, ensuring a consistent supply chain and robust production framework that will support the nation's aviation ambitions well into the future. The PD-14 represents more than an engine. It's a milestone in Russian technological independence and a commitment to innovation. With advanced engineering, robust environmental credentials, and a comprehensive support system, the PD-14 is not just powering planes, it's propelling Russian aviation forward. As production expands, the PD family will ensure Russia has a reliable, homegrown option for its airliners, marking a new era in aviation that embraces efficiency, resilience, and global competitiveness. This engine's journey is only beginning, but it's already a powerful symbol of Russia's commitment to the skies.